Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about forming equations. Let's link to what we already know. We've already talked about writing algebraic expressions. We drew a flowchart and we used the flowchart to make an algebraic expression from a series of steps. Pause the video and check with this simple step here in part 1 that you can write an expression to explain that. Okay, I said when doing this, draw a little flowchart. We're going to start with x. I said we are told up here to double it, i.e. that means multiply it by 2. When we do that, a mathematician would write that as 2x. So the expression is 2x. Remember, an expression is maybe some numbers, some letters for algebra, and an operation. In this case, we've done a multiplication. Okay, there we go. But this video is about forming equations. Equations, we know, should have an equal sign. And so let's see where they might arise. A very similar scenario here. See if you can spot what's similar and what's different. I'm thinking of a number, I double it and get the answer 27.2. What's similar? Well, I'm thinking of a number. No one's told you what the number is, or you haven't revealed the number. So it can be anything. So I'm going to call it just x, let's say. Give it a letter. So I'm thinking of a number is kind of like starting with x. Then we were told to double that number. So I doubled the number, which we did above as well. And this is where the difference comes in. We are told what you get as a result of thinking of a number and doubling it. You get the answer 27.2. So it's very similar to what we've done above. We thought of a number, i.e. start with x. We doubled it, so we multiplied it by 2 and get 2x. The only thing is now we know that this thing is 27.2. So I can just say here, this 2x that we've got, I'm just going to say that's equal to 27.2. Now we don't write our equations upside down like that. We would go over here and writing it as an equation, we would say that 2x, our expression from thinking of a number and doubling it, must therefore equal to this answer 27.2. And there we go, we have formed an equation from this thinking of a number problem, nice and easily like that. Now just to start with, draw the flowcharts with me, bear with me using that. It's going to be really useful when we come to solving these things. So just bear with me and do the flowchart to start with, but later on we're going to start dropping it and just getting into the nitty gritty and just using algebra. Right, let's try another one. You've done a problem like this before. Write an expression that results from the following. You start with x, triple it and subtract 5. Pause the video and just double check you can write the expression for that. Well, you would have started with x if you drew your flowchart. Triple it means multiplied by 3. You would get the expression 3x. Then you would subtract 5 from that. So we're going to get the expression 3x subtract 5. So just double check you can do that. Make sure that makes sense to you. Now, how are we going to form an equation? Let me give you a problem that's like that, but from which an equation can be formed. Form an equation from this information. I'm thinking of a number. Remember, I'm thinking of a number is like starting with x. I triple it, that's what I did up here, and I subtracted 5, that's what I did up here, but this time we're told I get the answer 37. So with the flowchart, we know this whole flowchart is still appropriate here. That was our original flowchart. I'm thinking of a number x, I triple it, I take away 5, but this time we know that this thing we ended up with here is equal to 37, which I'm going to write in nice neat algebra over here as 3x subtract 5 is going to equal 37. And there you go, that is the equation formed. This thing here is the answer. I have formed an equation from this problem. Okay, let's try some varying examples. You should be ready to do them yourself now. Pause the video, have a go at both of these. Maybe draw the flowchart if you need, but end with an equation that you get when you do this. Okay, I'm thinking of a number, x, I half it. So I'm dividing it by 2. How does a mathematician write x divided by 2? They write x over 2, that's right. And I know that gives me 13.3. So writing it in nice neat algebra, x over 2 must therefore equal 13.3. Okay, that's my equation formed. What about this one? Make sure you try it. I'm thinking of a number, x. I subtract 5.2, so I'm going to subtract 5.2. I get x subtract 5.2, and I know that gives me the answer 13.3. So this thing here, this expression must equal 13.3. Writing it in a nice neat one line as my final answer, x subtract 5.2 must be equal to 13.3. Done. My equation is formed. Let's try slightly harder ones. Now pause the video and have a go at both of these, and also have a think about what's similar about them and what's slightly different about them. Okay, looking at them, everything looks super similar, other than, in this case, the number I'm thinking of, I double it first, and afterwards I add 3, whereas in this case here, I'm going to add the 3 first, and afterwards I'm going to double it. But in both cases I get the same answer. Let's see if our algebraic equation looks the same or different. What do you think it's going to be, the same or different? Well, let's check. In this case, I'm thinking of a number, there's x. I'm going to double it, so I'm going to double x and I'm going to get 2x. I'm going to add 3, and I get the expression 2x add 3. And I know that's equal to the answer 10.4, so I can state my equation that from this, I formed my equation 2x add 3 must be equal to 10.4. Done. Let's see if we get the same here. I'm thinking of a number x. I add 3 this time. Okay, I'm going to add 3 first, so I'm going to get x add 3. Now I double that. I double this. Now you've got to be careful here. You're doubling this whole expression. You are doubling x add 3, which you must put in brackets to say you're doubling all of x add 3. If you were to write this by mistake, which is an easy mistake, you've just doubled the x there. You need to double the x add 3. Okay, and you know this is going to be equal to 10.4. Now look, we formed our equation. 2 brackets x add 3 is equal to 10.4. And that's different from above. See, above it was 2 lots of x plus 3 is 10.4. This here is 2 lots of brackets x plus 3 is 10.4. And they're very different from each other, and solving them is going to be different. So hopefully that makes sense. Last example. Pause, do try this before I show you the answer. Okay, I'm thinking of a number. I divide it by 3, so I'm going to divide by 3. A mathematician writes that as x over 3. And then I add 11, so I'm going to add 11 here, and I get myself x divided by 3, x over 3, add 11. And I know that's going to equal 12. So I can state my equation, x over 3 add 11 is equal to 12. Now the one below looks awful similar, but the adding 11 happens first and the dividing by 3 happens second. Do you think we get a similar equation, or do we get a different one? I'm sure you got the hang of it. We're going to get a different one, aren't we? Let's double check we understand how it's different. You start with x, you first add 11, you get x add 11, and then you divide all of that by 3. So the x add 11, we should put a bracket around it, and we should say divided by 3 like that. And that is going to equal 12 in this case. So the equation we're solving here is x add 11, all of that divided by 3 is going to equal 12. And we can put a bracket around there if we want. We do or we don't have to put a bracket, both are fine. But that's solving a totally different, that equation there is a totally different equation to that equation there. And hopefully you can see, just by changing the order of what happens, the equations that we form are different. That's basically it for this video, other than to show you what we're doing in the next video. It's all very well forming these equations, so what, you might ask? What we're going to get onto in the next video, someone's going to ask us, what was the number you started with? What is x? And i.e., we are going to try and solve this equation or this equation to find what the original x was. So that's it for this particular skill. Tune in to the next skill to see how we're going to solve these equations. Thanks for watching.